Okay, so in this video, we will be talking about how to solve cubics in a relatively fast manner. And in order to do so, we'll be solving cubics using a quadratic and then plugging in the solutions to the quadratic to get the solution to the cubic. So first, we want to get rid of our x squared term. And by doing so, we have to set x is equal to y minus b over 3a, where b is 3 and a is 1. So we end up getting x is equal to y minus 1. Now we could write our cubic already, but we want to first calculate what our values are. So we want to just write a little underscore to represent values. And since we don't know if it is positive or negative, we will leave it as negative for now. In case if we do get a positive solution, we just add the cross. So now we want to go ahead and find what our constant is going to be. And to do so, we're going to just plug in -1 into x to get what our value is when x is equal to -1. And here we're going to have -1 plus 3 plus 4 plus 3, which is going to give us +9. So we have +9. And to find x, we want to go ahead and take the derivative. And we're going to write the rule for the power rule in order to take the derivative of any polynomial. So it's going to tell us x to the power of n, and the derivative of x to the power of n is n times x to the power of n minus 1. Since we're just moving n to the front and subtracting by 1 at the same time, we will end up getting that the derivative of x cubed plus 3x squared minus 4x plus 3 is 3x squared plus 6x minus 4. And now we will go ahead and plug in -1, where we will get 3 minus 6 minus 4, which is going to give us -7. So it's going to be -7x. So we want to go ahead and erase the little underscores now since we don't need them, since we have our values. And getting rid of the derivative since we don't need that anymore. And in order to solve this, we want to go ahead and move 7 or -7x to the right side since it's negative and we want our coefficients to be positive. And now we can go ahead and solve for u and v, where we have to get -u minus v is equal to 9, and u times v is equal to 7 over 3 cubed, which is just 343 divided by 27. And now what we can do is find u or v from our second equation and then plug it in directly into our first equation, where we are going to go ahead and solve for u on our second equation. So we will get u is equal to 343 divided by 27 times v. And now just plugging in u directly into our first equation now, we will end up getting that -343 divided by 27v minus v is equal to 9. We're just going to multiply by v to get -v squared minus 343 divided by 27 is equal to 9v. So moving 9v to the left-hand side, we get -v squared minus 9v minus 343 3 divided by 27. Or we could just divide by -1 to get v squared plus 9v plus 343 divided by 27 is equal to 0. And now we can go ahead and solve for v in terms of solving it with the quadratic formula or completing the square. So we have v is equal to -9 plus the square root of 81 minus 1372 divided by 108, or not 108, by 27 divided by 2. And then we can go ahead and simplify where we have -9 plus the square root. And it should be plus or minus, but we're only going to use one solution, which is the positive sign for the square root. So we will get 815 divided by 27 over 2. And with this, we can go ahead and distribute the 2 down here into the square root and the -9 to get v is equal to -9 over 2 plus the square root of 815 divided by 108. And now we can go ahead and directly plug in v into u, but we're not going to do that since we're just directly going to find x now. And what we have to do now is set x is equal to the cube root of u plus the cube root of v. So now we just plug in u and v, and we will get x is equal to the cube root of 343 all over 27 times -9 over 2 plus the square root of 815 divided by 108 plus the cube root. That was a horrible radical sign. The cube root of -9 over 2 plus the square root of 815 divided by 108, which if we plug into a calculator, let's go ahead and do that. It is going to give us x is equal to -3.14092334. We're just going to leave it at 4, which is indeed a solution to our depressed cubic. Since if we just go ahead and plug in x equals -3.14092.334, we're going to get, let's see, so we're going to take the cube of that. So we will get, let's write it in yellow actually. It is going to be -30.986. We're just going to write the first 3 digits, minus 7 times that, plus 21.986 is equal to 9. And if we, or no, it's -9. So we have -9 plus 9 is equal to 0. So seeing that, we get that our solution is indeed -3.14092.334. And to solve for the other two solutions, we could just go ahead and factor this out and solve a second quadratic using the quadratic formula. Or we could simply just use the roots of unity, where we will go ahead and just clean some of this up. And since we don't need v or u anymore, we'll just clean that as well. Or just get rid of that. Now that we have x, we can go ahead and take the roots of unity to find the solutions, but we'll do that later. So now to get our solution to our original cubic, we just have x is equal to y, where x is y in this example. We're going to have x is equal to this expression here, minus 1. And we're going to get x is equal to the cube root of 343 divided by 27 times negative 9 over 2 plus the square root of 815 divided by 108 plus the cube root of negative 9 over 2 plus the square root of 815 divided by 108 minus 1. So that is our solution to our general cubic. And we don't need the depressed solution anymore. So we already have our solution to our cubic, which now we can go ahead and find it. Or we already found it, but we can go ahead and find the other two solutions by just setting x is equal to the whole expression again, 343, which is just 7, divided by 27 times negative 9 over 2, plus the square root of 815, divided by 108. And then we're going to write the roots of unity as blue, times negative 1 plus I root 3 over 2 plus the cube root of negative 9 over 2 plus the square root of 815 divided by 108. And then again, the root of unity, negative 1 minus I root 3. There's a bad I. We'll just leave it as that. And minus 1. And we can do the same thing, but we're just going to be rewriting the whole thing with the second root of unity being this, negative 1 minus I root 3 over 2, and negative 1 plus I root 3 over 2. Since we're just going to be switching the signs, there's no use for us to write the whole expression again. But that is our first cubic that we were able to solve. And we're going to go ahead and look at a much more difficult cubic and solve it. So let's go ahead and clear up some space and make a new equation. We're just going to keep that. We'll move it to the right hand side. So let's go ahead and write a new cubic, which is x cubed plus 2x squared minus 3x plus 6 is equal to 0. So here, let's just write that again. X is equal to y minus b over 3a. And we have that x is equal to y minus 2 over 3. So we're going to get a fraction. And we will go ahead and write our cubic already. But this time in terms of y, since that was my mistake for not doing that in the previous example. So now we have minus x plus, or minus, so just leave it as that, is equal to 0. So we want to go ahead and calculate 2 over 3, so, or negative 2 over 3, which is negative 8 over 27 plus 2 times 4 over 9, which is 8 over 9 minus 2, or plus 2, plus 6. And let's just go ahead and group these terms. We have negative 8 over 27 plus 24 over 27 plus 8. And now we will have 16 over 27 plus 8. And now, if we multiply 8 by 27 and converting it into a fraction, we will have 216 plus 16. We get 232 divided by 27. And it doesn't have any factors of 3 or anything. So that is our y value when y or x is equal to 0. So that is when x is equal to negative 2 over 3, we get 232 divided by 27. And now to find our x, we're going to do the same thing by just finding the derivative of the cubic, where we will get 3x squared plus 4x minus 3. Going ahead to plug in negative 2 over 3, we get 4 over 3, because that is 4 over 9 times 3, which is 4 over 3, plus or minus 8 over 3, minus 3, or minus 9 over 3. Now I can go ahead and group everything, where we will get negative 4 minus 9 over 3 is equal to negative 13 over 3. So we get negative 13 over 3. So that is our depressed cubic. And now I want to go ahead and find what x or y is now, so we could replace it for what is here and solve for x. So we want to go ahead and move negative 13 to the right side again, or the x value, to get 232 divided by 27 is equal to 13 over 3x. So we will go ahead and do the same process we did last time. So negative u minus v is equal to 232 over 27. And u times v is equal to 13 over 3 all over 3, which is going to be times 9, or 3 times 2, which is 9. And we're going to cube all of this, and we're going to get 2,197 divided by 729, and that is what we're going to have, and we're going to divide by v to get u again. So we have u is equal to 2,197 divided by 729 v. We're just going to plug in u again for u in our first equation to get negative 2,197 divided by 729v minus v is equal to 232 divided by 27. And here we're just going to multiply by v. But since we have, again, our coefficients all negative, we're just going to write it positively. So we have v squared plus 232 divided by 27 V plus 2,197 divided by 729. Now we can go ahead and multiply by 729 or simply just write it out like this. So we're just going to solve it like this, where we find V is equal to negative 232 divided by 27 plus the square root of 232, that is 53,824 divided by 729 minus 4 times 2,197. It is 8,788 divided by 729. So now we just add that and we will get that it is equal to negative 232 divided by 27 plus the square root of 45,036 divided by 729 over 2, where it will give us negative 232 plus the square root of 45,036 divided by 54. And we can find what y is now. So we will go ahead and do that. Y is equal to, we're going to find what v is first, since it is the cube root of u, which is 2,197 divided by 729 times negative 232 plus the square root of 45,036 divided by 54 plus the cube root of negative 232 plus the square root of 45,036 all over 54. And we can go ahead and verify that for our cubic here, which is the press, but we're not going to, since we will verify it when we get x all together. So now with that out of the way, we're going to get x is equal to the cube root of 2,197 divided by 729 times negative 232 plus the square root of 45,036 plus the cube root of 2,197, or no, not that, negative 232 plus the square root of 45,036 divided by 54 minus 2 over 3. And if we simplify what's inside the cube roots, we should get a much more simpler variation of our solution. But first, we're going to go ahead and verify it. And we will go ahead and see if it is our correct solution. And we see that our solution is going to give us x is equal to or approximately, we're just going to write down the first 5 digits, negative 3.4000, or no, 3.4008846, and so on. And let's go ahead and verify that that is our solution to our cubic. So if we plug in this, the approximation, just with the first few digits, we should see that it does indeed give us 0. So I'll write down the answer in a little bit. With the decimal that we were given here, or that I wrote down, we should get that f of x, or f of x for this, which is our cubic, should be 0, or let's write in scientific notation, 1 times 10 to the power of negative 8. Which we should get is 0.000001, and that is indeed telling us that when x is equal to negative 3.4008846, or this huge expression here, that x is the solution, since f of x is equal to approximately 0. But if we were to go ahead and use the whole root, we would end up getting that it is exactly 0. So with that, we have solved a much more difficult cubic where we can't simply depress it and we simply just get fractions as we saw. And sometimes we have to depress the cubic in order to be able to solve the general cubic, because we have several different cases where we have depressed cubics, since there are only very few cases where there are cubics that are written in this form: x cubed plus px is equal to q, and x cubed plus q is equal to px, which is the one we mainly we're looking at. We also have x cubed is equal to px plus q, and here I'm going to just write the intervals where p is greater than 0 and q is less than 0, since it's negative, and q is greater than 0 and p is less than 1, or not 1, less than 0. And here we're just going to have p is less than 0 again, and q is less than 0, since these are the three main types of cubics we could get just from mixing around p and q, giving negative and positives. We also have this one, or which is basically this one, but where x cubed is negative, which is the same thing as this. So that's why we cancel out most of the other ones, because they're going to give us either one of these. So we've been looking at this case primarily, so we don't need to go ahead and look at that anymore. And we want to go ahead and look at either one of these two cases. So we'll look at the bottom one later. We're just going to go through a quick review on how to solve these cubics. So I'm just going to write down the method to solve. So we will get, in order to solve for x, we have to find u minus v is equal to q. And u times v is equal to p over 3 cubed. And x is equal to the cube root of u minus the cube root of v. And we already done this part since we just need to go ahead and solve for u or v. But in this example, you want to solve for v, because then if you solve for u, because if we go ahead and solve for u, we're not going to get our answer from this equation. Instead, we will have to go ahead and switch the sign, where we have x is equal to the cube root of v minus the cube root of u, and which is why it's better to just go ahead and solve for v. And we can go ahead and plug in u or v, but it's up to your preference, whichever you find easier. But the way I do it is go ahead and just divide by v for our second equation to get u is equal to p cubed over 27v. And that's how I get the answer for u and v and the solution. And for the other case that I mentioned, we're going to go ahead and get rid of this one and write x cubed plus, or is equal to px plus q. In order to solve this specific type of cubic, we basically want u plus v is equal to d, or equal to p. Actually, no, it's q, because d is a constant in the original cubic. And u times v should be equal to p over, or p cubed over 27, since we already looked over this. But this time, instead of a negative, we have a positive sign, which is telling us that we're going to be solving for this cubic. So we're going to do a quick example for cubics with a whole solution. So we'll go ahead and look at the first case, where we have x cubed plus 2 or 3x is equal to 2. And we should be able to automatically see that x is going to be, let's check. It is going to, actually no, 4. So we have a whole solution. So let's go ahead and solve it using the quadratic. But first we have to note down what u minus v is, where u minus v is equal to 4, and u times v is equal to 1, since 3 divided by 3 is 1 and 1 cubed is 1. So we will go ahead and solve for u. And since we're solving for u, we have to use x is equal to the cube root of u minus the cube root of v. So we're going to go ahead and solve for u, or for our second equation. So we get u is equal to 1 divided by v, and we get u is equal to 1 over v. So we plug u in for our first equation, where we will end up with 1 over v minus v is equal to 4, and multiplying by v, we have negative v squared plus 1 is equal to 4v. So now multiplying by negative 1, we get v squared minus 1 is equal to negative 4v, where it will give us v squared plus 4v minus 1, where we're going to solve for v. So we get v is equal to negative 4 plus the square root of 20, because 4 squared is 16 and negative 1 times negative 4 is 4, so 16 plus 4 is 20 over 2, and we will get negative 4 plus 2 root 5 over 2, and that will give us negative 2 plus root 5. So that is what v is, and we'll just go ahead and directly get x. So we have x is equal to the cube root of 1 over negative 2 plus root 5 minus the cube root of negative 2 plus root 5, which then right here will go ahead and give us that x is equal to 1. But we want to go ahead and find out what the cube root of 1 over negative 2 plus root 5 is. So we'll go ahead and get the first or the decimal value for it, so we can see if it does indeed add up to 1. So we have 1 divided by negative 2 plus root 5, which is 1.61803. We're just going to leave it as that. And the negative 1, or what's on the right side, is going to be minus 0.61803. And we see that if we just add this, it's going to be 1. And if we verify that we have 1 plus 3 is equal to 4, which does indeed satisfy our cubic, and that is how to solve these types of cubics, where we have q on the right side. And to finish off the video, we'll go ahead and solve the final case we have, which is the one I mentioned earlier, x cubed plus, or no, is equal to px plus q. So we're going to go ahead and solve it. But let's get x cubed is equal to 6x plus 9. And we'll go ahead and find u and v. So we will get that u plus v is equal to q, which is 9, and u times v is equal to 6 over 3 all cubed. But we see that this is 2 because 6 divided by 3 is 2, so 2 cubed is 8. And we could kind of see what our answer is going to be, since 8 plus 1 is going to be 9, and 8 times 1 is going to be 8. But we want to be sure that that is, but we have a possible candidate just automatically that u is approximately 1 and v is approximately 8. And we could go ahead and say the same thing for u being 8 and v being 1. So we have possible candidate solutions basing that 1 plus 8 is equal to 9 and 1 times 8 is equal to 8, which satisfies the condition, but we want to see if it will go ahead and satisfy our cubic. So we can go ahead and just plug in u and v for the cubic or the cube root. But first, let's go ahead and solve it using the quadratic, where we will get u is equal to 8 over v, and we get 8 over v plus v is equal to 9. And then we just go ahead and multiply by v, and we get v squared minus 9v plus 8. And we can go ahead and factor this since it is factorable. We have to go ahead and do v minus 1 times v minus 8 because we want to find a number that multiplies to 8 but adds up to -9, and -1 and -8 are those solutions where we will get v equal to 1 comma 8, which does indeed satisfy our v values 1 comma 8. And just plugging in v, we get u is equal to 8 divided by 1 comma 8 divided by 8, where we will get 8 and 1. So that satisfies our two other solutions for u. And we can go ahead and get x is equal to the cube root of u plus v, which is 1 plus the cube root of 8. And we will get 1 plus 2 is equal to 3, which is going to give us that it is indeed our solution for our cubic. So we get x cubed minus 6x minus 9. Let's just plug in x is equal to 3. So we have 27 minus 18 minus 9. That gives us 27 minus 27, which is indeed equal to 0. So that concludes this for this video. And this is a faster way to solve cubics, but it does take some practice to be able to fully master it. And it shouldn't be that hard once you get the hang of it. So again, thank you for watching and have a good rest of your day.